that work okay?
Yeah.
Okay.
Is it okay that it's split screen?
Yeah, I mean, if everyone in the class okay with that, it's split screen? No riots in the front row? You can sit over here.
Might be legally blind from far away.
Hey, that's what glasses are for, you know?
Sorry. Sorry.
I'll start off then. Yeah.
Yes, I believe I can see the functions. Okay.
Or under 8.
Under.
This could be under.
Under? Why?
It's no longer the first and second.
There's
Some of us right now. That's 8 right there.
guys over under. We have one more.
Who's missing? I was counting. I thought it was 6. You can see Will on top. We'll see it.
Lucia, Angeli, and then.
Angeli's here though.
Actually, gonna come.
Yeah.
Okay, how's everyone doing? Have you filled out your availability for the student help session? Have you not?
Oh, no. Oh, no.
Yeah, call me out. I don't know what you're talking about.
Okay, I'll show you at the very end of Will's presentation today, because we're going to talk about two things today. First, he's going to be talking about user-defined functions, and then we'll talk about like good programming style. And you'll recall that good programming style accounts for 10% of your assignments. Okay, if it doesn't look good, it doesn't communicate well, it's getting a 90 at best, right? To get the 100%, you have to demonstrate good programming style. Okay. Will's going to talk for like 15, 20 minutes, however he feels. And then we'll talk really briefly about how I want the homework presented, because you will have your first homework due Friday. And I will also show you the student help sessions. And after you've put in your availability today, I will set student help sessions for the remainder of the semester. This class will get its own dedicated 1-hour session. Okay. I'm going to try and give us topics that we'll cover in those sessions, so you don't have to show up with questions. You can just show up. That seem reasonable? Because my house is still not okay to live in, and that means my dogs are just in an apartment somewhere, I won't come in Tuesday, Thursday until I can move back in. But once I'm in person, we'll have them in person. Otherwise, they'll just be on Zoom. Does that work? For this class, it works well because we'll be looking at code. But for other classes, it helps to write on a board. Okay. Questions, comments, concerns? Take it away.
So last week we talked about, or maybe not last week or 2 weeks ago, we talked about in section 2.2 functions like log and square root, which are taken from the math package. And there's also other what are called built-in functions like len for length or range or max and min or sum. And those are built-in functions. But sometimes we need technical functions that aren't available as these built-in functions that produce a specific output that we desire. And I'll show an example of that that's in the book. So here they have calculating the factorial of a given number, like a function. And every time you want to calculate the factorial, you could define, first you would define what n is, n equals something. It's not done here, but you would do that, like n equals 6, and we know that the 6 factorial is 720. And for k in range from 1 to n plus 1, we find that doing this, I didn't write it down, but doing this would give 720 if we used n equals 6. But we can streamline this into a shorter package as a user-defined function. So here we have def factorial n is the argument, colon, and then we have what's inside the function, f equals 1, and then we have a for loop, 4k in range, and this is a discrete, it's not continuous, so that's why it goes from 1 to exclusive n plus 1, so it doesn't include, that's why they have the plus 1, and f multiplies equals k will multiply the number by k and equal it out and give us our return function. So I have that here. And just to show, let's see, indentation matters just like for loops, while loops, and if statements or conditionals. So if I have this will run an error, unexpected indent, and you have to make sure all the indentations are correct. So like for the for loop, it has to be one indentation more. And then I want to ask from from the code I have on the left, I don't know if you can see it very well. So what does people think? Raise your hand if you think factorial of 6 is going to be the output of this. Raise your hand if you think factorial of 8 is going to be the output of this. No one? Okay. Well, so just like having a variable and you initialize the variable, these are not like print statements. So if you have factorial 8 and then factorial 6, it's not going to print both. It's only going to print the last one that you did. And then secondly, but that's not the same for the return statement. So return f, this function is returning f, but it's not returning k. So if I switch them and k would be 6, then I'll get 6. So it's kind of like the opposite of what this lines are doing, kind of. It's hard to explain, but yeah. And then if I include B next, then what's going to happen is there's going to be no output because it's reading that last line and it's not printing. I didn't put print here. Now it outputs. So I have to put that print. Otherwise, it's just as if it's a variable and you're just like stating the variable. And then return statements do not exist outside of functions. That doesn't work. So you get an error there. That's important. Yes.
So instead of using print, you're saying you can use the return to show what you're doing in that loop up there?
Oh, like this return B? No, I'm saying it doesn't work. I'm saying I'm getting an error.
But it works for the one above, right? The one, the F and the one.
It doesn't work because it's not indented into the function. But if you indent it into the function.
Right, it has to be inside the function. And then if I just comment this out and I have this one, I'll just say, yeah, it'll return F. I'll just get rid of this one. So you still have to state a function factorial and then give your argument 6. And then it'll just output. Oh, actually, no, it won't because this is not commented out. And it'll just output whatever the last line is. So factorial 8 is that. But if you want to print both, you need You need that. And then in the book it shows you can do operations on variables as long as they're defined. So here I have defined r equals 2, s equals 3, factorial. This should be factorial 8. And I do get that. So that works. So the return statement sets, I just went through that. It just sets the what's the word I used? Return statement sets the value of the factorial function to whatever it is in front of the return. Okay. Variables created inside of a function only exist within that function. So if I say I should get, let's see, k should equal 6. So if I say print 6, k, I should get an error. Yep. K is not defined. So k only exists within this function. And I think n also. Yeah. So n only exists within that function because it's the argument. And k is just a variable. And I think f2 would not work either. Yeah, f would be a better example. So f, it only exists within that function. However, if I define, it does not work in the reverse. So if I say e equals 5, and I say print e, I will get 5. Wait, if I say print e within the function, and then I say print factorial 6, I'll get 2 e's within it because I have the variable defined outside the function, so it exists within the function as well.
People understand what's happening here?
Why does it print twice if you're only asking it to print once, the E?
Because I have 2 separate times I called on the user-defined function for factorial 8 and factorial 6. If I just did that, oh, maybe it would do it twice. I don't know.
Well, no. This is a great example. It's a great example. Go back. Just undo it. Okay. So what happens here? Look at the output. 5, 5, 7, 20. What's happening? Not well.
Is it that because it's already indented, so it's gonna print the E, but then once it's out of the indentation, it's still thinking that it has to print it again
Nope.
because.
Look at how many times he calls it. He calls it once, factorial 8, right? So regardless of whether you print the result of factorial 6, here, you're always going to print E. Right? This could be a statement like factorial is running, so that you know every single time that it did something. Right? But he ran it twice. He only asked it to give the output once. Right? This is an arbitrary print decision. Does that make sense? So you should get 5, 5, 7, 20. Is that what you meant?
Yeah,
Fine.
And okay.
So even without the last print, because it's the last thing it reads, it should still say 5, 5, 7, 20, right?
No. So what happens if you get rid of that other print statement, print factorial 6?
it'll only print one time.
Oh, now it has a space, okay.
Ah, right.
So
5, 5 are both print statements, and then it just says factorial 6,
Oh,
right?
because it's the last
The last
line.
output.
Okay.
If you have another return F, will it print 3 times?
So these returns, right? Let's say you have return F, return K. Remember that they don't care, right? They only take one return. So the fundamental thing to recognize here is that this is a black box. Okay, user-defined functions, and generally speaking, I'm sure Will's gonna talk about this in a few seconds. You don't put them in their code, they don't act like code, right? You don't run along and then find one. You define them beforehand and they exist fully on their own. They take inputs in. And they take inputs in the parentheses. And they give something out sometimes only with the return function. Sometimes they don't have returns. Sometimes they just do something, right? Okay.
User-defined functions allow us to take complex calculations and streamline them into single functions at the beginning of our code, and then like use them later throughout the code. So like if we were working on that satellite problem where we took in the height and as a function of height and got the time period of a satellite, instead of writing it multiple times for part C and D, we could have just written one function and then written like period parentheses 50 or whatever the height was, and then do that multiple times to get our outputs. That's how that would work. I don't have an example, but it just, that I think
No, that's a great example.
User-defined functions can have multiple arguments. So there's an example here where they use converting from cylindrical coordinates to a distance with r, theta, and z. And of course, it kind of addresses that later in good programming style. But theta they define as it's defined within the argument, but they write it out as theta as a word. And then they haven't written it here, but usually you would import from the math package cosine, sine, and square root. And then you just have the conversions from polar to Cartesian coordinates and then the distance formula. Then that returns D. And you could say print this distance, or just you wouldn't want the print in, you wouldn't want to say print D instead of return D, because you want to do something like set a variable s equal to that distance. And so you say set, so s equals, it would look like s equals distance r theta z. And you can't do that if you put the print in there. So that's important. You want to, yeah.
Question?
Mhm.
So, two things. Once you define a function, can we carry out all the other cells, or you have to redefine that specific cell?
You just have to run the code that will run that cell that has the function. And then when you rerun another that like another cell that has the function like distance parentheses something, it'll give you the new output. Yeah.
So then what you're saying that is that you always want to have a return to like cap off the define?
Probably at least one. And then it'll read the first one. So like here, I put return F, return F. If I put return K, it's only going to read this line, the first line. Does that answer your question?
Yeah.
Okay. Yeah, import those functions, sine, cosine, and square root. You can use arguments that are integers or complex numbers or lists and arrays. You want to use a list if you want to return a vector. So here in this example, they have from Cartesian, convert from polar coordinates to Cartesian coordinates, and then return a list. And that list is supposed to be like a vector of position. So that's useful. Or if you use the array function and make sure you designate the data type as float, then you can return an array. instead replace return position with or I think you would replace that. You would replace return position with return array xy dot xy comma float. Oh, here's important. You can return 3 or more values using multiple assignment. And this is similar to in section 2.2 when we defined or initialized 2 variables at once in one line, x comma y equals a comma b. You can return a comma b. So let's try it. Let's try f comma k. And this should give 720 and 6. And I did something wrong. Oh, that's why. There we go. Yeah. So now we can return 2 variables or 2 arguments, just like that. Does that make sense? Mm. The defined functions can return no value at all. So I showed instead of having return here, we can say just print. Oh no. My laptop is dead. But not dead, but like, can I plug it in here?
Yeah.
I'm so sorry.
It's okay. We're getting towards the end anyway. Yeah, so you can have them do nothing, right? So you'll play with that today. Let's transition if that's okay, Will. And I will just share the we'll talk about good programming practice at the end of the discussion today. So here's the user-defined functions, just the part that we were talking about here. Let's see where to go. All right. This is what you're talking about?
Yes, no value at all.
No value at all, right? And we're going to do some experiments using user-defined functions. Some of the things that I'll just help fill in a tiny bit here is some of the words that we were talking about. So I think there was a question about what does the computer know? Where can you define a function and then where will it be known? So once you've put it into the memory, so I want you to think of the IPython notebook as one continuous framework. You define stuff at the top, constants, import packages, and then that's known everywhere, except for inside of user-defined functions. So for example, this is like a little black box, and you have things in here that are called local variables. They're only present inside the box. Everything that's outside the box is called a global variable, right? And similarly, so if you import something like sign, that will now be known to all parts of your code. And if you try to use, for example, let's say you call this user-defined function fun function 1, okay? And you're going and you're typing along, and then later on you try to set fun function 1 as the variable name for something else, you're going to screw yourself up. And this is, again, we're going to get into a little bit of like good programming style here, but this is another hint. Don't let, just because it's in the book and you see this constantly, F and Z and A and D, feel free to use a little bit more words here because you're going to avoid having defined something like your user-defined function F. What does F do, right? Just describe what it does. Like the earlier one he had was, what was it called? The first one you made? Factorial, right? F factorial, which one of those is helpful and unlikely to accidentally be called a variable, right? Make sense? Okay. We're going to use this probably not as often today, but much more in the future. I do just want to point out a couple different things here. For good programming style. Have you read this already? Everyone's read this? Yeah. So, oh God, what happened? The first 4 points. People have the book in front of them? What's the first part of good programming? What? Leave comments. Yeah. So one thing I was noticing Will was doing, and you don't know that you have this capability yet, is instead of deleting a whole line, sometimes you just want to comment it out, right? So you can easily do that. I believe on PC, it's shift, command shift, or command. Hold on, what do you guys don't have command? You have control backslash. And I think that should get rid of the whole line. We're going to practice this. But what you can do is you can block out entire sections of code. And that's really helpful because if you're like, oh, I just want to see how well the code works up until this point, just comment out the rest of it, and you don't have to delete it and put it somewhere else where it might get in trouble, right? Leaving comments is really important, especially in this class, because it's how you communicate with me. It's how you demonstrate that you understand it to me. And that's the thing that matters, right? Your own personal understanding doesn't matter. No, just kidding. So that's important too. You're also communicating with your future self. So let's say you write really good code this week, and then in 3 weeks, you're like, oh shit, I have to do something similar. You can just grab your old code and you have a little message of this step and this step and this step, and now you know how your code works, right? It's much easier to digest code that has good variable names and good comments. It takes longer, but it's better. Okay, what's the second thing it says on this page that you can't see? Perfect. I'm ahead of the game. What's the third thing you do? Use the right types of variables, right? So think about the problem ahead of time. Are you going to need integers? Are you going to need a list? Are you going to need an array, right? Thinking about that ahead of time just saves you the issue of having to define a bunch of stuff all in a weird part throughout, right? You can define all your constants at the beginning, all your variables and arrays, do it all in one place, and that way there's no mistakes, right? 4.
Functions first.
Functions go first. These user-defined functions go at the very top. And I'm going to show you what that looks like today. So it should be a comment with your name, especially if it's your homework. It should have all of your imports. So import numpy as np, import math, import time, import os, whatever other packages you want to put, that should all be at the top. I should not see the word import numpy more than once in your book, because that means you don't understand how you're importing it, right? And all of your imports, once you've gotten them, you just get to keep collecting them. So usually when I start a new project or I open up a new IPython notebook, I just copy and paste all of the things that I know that I tend to use. And even if I don't use it that time, it costs me nothing to import it. Maybe an extra 5 seconds at the beginning of my day, right? So I grab it all, copy, paste it, throw it in the front. And it's what we call front matter, okay? After your imports, you have your user-defined functions. And then you have the code that uses it, okay? And I'm going to show you this structure. Next one.
Give your constants names.
Yeah, give your constants names. Atomic number instead of A. X position or X underscore POS, right? That's better than X. Okay. X underscore VEL, X velocity, right? That's just an easy way that when you read it, it seems like words again, as opposed to a bunch of letters that don't make any sense. 5.
That was fun.
That was 5.
Define functions or
Good. Just because we learned a new tool doesn't mean that we're going to use it every single time. You will immediately have this instinct that everything needs to be a user-defined function. That's incorrect. Okay. So we have learned a couple different tools. We learned about while loops. We learned about commanding statements like if, right? We learned about for loops. And now we've learned about user-defined functions. So some stuff, like you were talking about constructing the period, right? And you know that you're going to put a bunch of different numbers in there. That makes sense. Create a user-defined function. Some operations we're not going to need to do a bunch of times, so it doesn't make sense to have a user-defined function. So if, for example, you're thinking about the Z and A one that does the atomic binding energy, and your first instinct is to look at that and say, now I need a user-defined function, that's incorrect. Because you can just as easily go through all the A's and all the Z's with two nested for loops, right? Make sense? User-defined functions are great for accomplishing a task that's going to change. So if, for example, you want to build something like, let's say we want to integrate the equations of motion. We want to figure out if I throw a ball, which direction it's going to go. So I'm going to create differential equations, and I'm going to hand this computer the position and the velocity, and it'll tell me where it goes next. You can do that with a user-defined function, right? As opposed to writing it over and over and over. Does that make sense? Okay. You should be talking to yourself. You should be writing on your paper, print out partial results and updates throughout your program. So Will had a great example. You could like print F as you're going, make sure that the thing that you're trying to compute is working, right? I also like to add little messages to myself. So for example, let's say something is going to run for 100,000 times, right? You don't want to wait 15 minutes to find out that it hasn't started. So how could you do that? You could go in there and you could have a little counter, and that counter says n modulo 1,000 print, this is working. Print the n, right? And watch the n go up, up, up. And so that even though it's not giving you the output yet, you can tell that it's running in the background. This is the origin of the status bar, right? It's that you want, for folks who are sitting there waiting, you want them to see that something's happening, right? Similarly, let's say it fails, okay? Let's say you have some code, some error. It's going to get to a certain point. You can ask your computer to print out information while it's in a loop or while it's inside of a piece of your code. And this will allow you to debug, right? Because you need to get in there sort of with the scalpel, sometimes with a hammer, and find out what's broken. Does that make sense? Okay, lay it out clearly. I think that goes without saying. Don't make it hard for me to read. And don't make them more complicated. If it can be done in 10 lines, do it in 10 lines. Okay? If there's two ways to do it the easy way. Okay? That's going to take some finesse. You're not going to feel good about that right away. But in like 5 weeks, you're going to be like, oh, I get how to do it easy. Does that make sense? Okay. Anything else? Questions, comments, concerns?
Talk about white space.
Yeah.
And I can't remember which number it was. But it was like, I thought it said have like a line of space, so enter between like a while loop and a nested while loop. Is that something that's gonna be?
No, I mean that's probably helpful for you just to see. They won't notice those enters. They notice sideways white space, up and down white space actually doesn't matter to them.
Is it,
Or at least in this version of Python.
is it, like, is that an example of good programming?
Yes, I do like seeing space because in that space I want to comment. So if, for example, let's take your factorial, right? Def factorial that, and then you had what, like a for loop for blah 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 blah, and then you had some stuff, right? That's all nice and tight. And it's like, oh, great, look at how many lines of code I wrote. Okay, that's fine. But if you say here, comment, this will take in F and spit out, whatever, right? Spit out whatever. And then you say, this for loop does the multiplying, right? If at every indentation you tell the user what's about to happen, you, the user, will understand it much better. Does that make sense? This print statement does blank, right? Okay, maybe that's obvious. But you never know, right? This return statement gives me an array of my X and Y that have just been updated. That's a great line that's just for you. Only you will see it, but will help you when you want to use that later. Does that make sense? Okay. So if you have spaces in between, it's going to look a lot nicer, right? So this might have one space in between this, which has a space in between. Okay. Does every single line have to have a comment? No. Does it help to have helpful comments? Yes. Makes sense? It's an art form. I'll yell at you for having too many comments, and I'll yell at you for having not enough. I won't yell. I'll try not to. Okay. Yeah.
Does that include our pair programming assignments to have a lot of comments?
Yes, those should especially have extra comments. So in that particular case, you can add them after, but it usually helps just to do it together, and that way, because the driver is sometimes not paying attention, the navigator can go in, add some comments. This is what I meant by this, is what we did. You can also write little statements at the end. This worked, and we can tell it worked, not just because it ran, but because it's a reasonable number. Some folks did the orbital period problem, and they ended up with an orbital distance of like 700,000 kilometers. So is that reasonable? No, why not? Because you asked for a 90-minute orbit, and we know that the space station orbits at about 400 kilometers, right? So we can draw on the fact that these are physical systems, right? That number just seems too high. I got a number, that's good, but it was wrong. And here's how I knew, right? Okay. So let's talk about the structure of your homework really quickly. What goes at the top?
Title.
Title. So I'm going to put a comment. Okay. And then?
Any imports?
Any imports. Good. And this doesn't need a comment. This is an import. Okay. User-defined function. Okay. For your homework, do you need your name? No, because it's yours, right? I hope it's yours. Anything else?
Constant.
Yeah, actually, we're not going to place them here. So this first piece is the thing that I usually just allow to be in its own box. When you create a cell, just create that cell and then just leave it at the top. And then if you have a different region, you can define constants in here, const equal. Maybe you set up your arrays or lists, right? And then that structure makes sense. Okay, and if I'm in here, I'm also going to write, maybe I have a comment about the units, or I have a comment here reminding me what this means, right? So what am I likely to scream at you about in the first week? Structure and comments. Having too many comments is bad. Having too few comments is bad. So you can't win, right? Is that frustrating? No, that's just life. Okay. You're learning a new language, right? Give yourself a lot of credit. You're learning how to make rocks talk, and you won't be perfect at it, and it'll be frustrating, Sarah, does it get better? Okay, good. So glad she said yes. Wow, that's really weird there. Okay, so let's do can we jump into today's activity? What do folks think? Okay, so whoever you haven't worked with yet, you've worked with someone, you don't get to work with them this week, you have a new partner. Folks finished 2.10 or not? Oh. Finish 210 with your old partner, and then we're gonna break up for 212. Okay. So you're still working on hold on, come on. You're still working on this one, right? The semi-empirical mass formula? Okay, well, don't everyone get up at once. What?
I wanted to show you.
If it makes it way easier, like these are mostly that. The course structure is for everyone to follow. You are only presenting on the material. If you have time, we can do an example or it works like it's necessary, you can throw that in there, but I expect everyone to have a look. Oh, here's it.
That should be able to see.
Like sexual.
Isn't that weird? No, that's the.
Yeah. Okay, who is not partnered up right now?
Yeah.
David's here.
Rerun everything? One team or two teams?
This is one, two.
Well, run six. Okay, do you guys want to work together? Work together with fun? Correct. Hopefully runs it. I plug it? Yeah, I do, but it might not be the right plug. What's your?
It's in.
Oh, yeah. Do you have a plug for the other end? Is that all right? Let me see it.
I think it's, yeah.
How is that not? But that's, so this is my plug. No. I thought this was. It's like 2000. It's 1 G.
I feel like if I wanna go back to school.
Cause I flip the phone, I flip the book on my phone. Oh yeah, that is not old. Old means like 10 years.
Yeah, well.
What's up?
So when we come into. Not just in there. I mean, get-
You can't get to it, no.
So.
So again, for pair programming, you can either do all in one document you physically do, or you can have 3 different documents with different problems in person. But you can't collaboratively work on one document. It's not like Google Docs. Right? Because think about it, if it were running on 3 different machines and one person has run it and the other people haven't, then it would know information that it's not supposed to. It has to be sequential, right? So what I mean by that is you can either choose, okay, this is all in Elliot's work. And then in your folder, you just write a note, like a text note that says, please check Elliot's folder for me.
Okay, so when we go home and, or we're like, then we can't go back and look at this. Because it's-
Right, so how would you get that? State information, because what you can do here, and so this part here, so at any time, I can take this thing and I can say, that's a lot of interest, file. And then I can download it. And I can download it to the computer and then I can email it.
So I can download.
Phone charger?
Yeah.
Yes. Yeah, that's fair. I almost never forget to charge anything, so. You have, Emmanuel, who, you have a partner? And who's your partner? Oh, David's coming. Yeah, okay, sorry.